So the next requested explanation is about a torque example from our practice test 2. And this is an actual experiment that I did in the lab. I think I made the numbers nicer, but it's definitely an experiment that could be done. So we take this meter stick and we balance it on a pencil. So the diagram of the scenario would involve the meter stick and then the pencil right here. And obviously, if you just put the meter stick on the pencil, it would fall toward the heavy side. But to prevent it from falling, we've put a weight on it here. So there's a little extra mass here. And we know a bunch of locations on this meter stick. We know that this is the 50 mark, 50 centimeter mark. And apparently the pencil is at 30 centimeters, and the extra mass is at 20 centimeters. So there's like lots of little bits on this ruler every 10 centimeters. There we go. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yes. So in order to calculate whether this thing is balanced or how to balance this thing, we need to know what the forces are that are exerted on the meter stick. And we know that the pivot point exerts a force that's upward on the meter stick. We know that gravity pulls downward on the meter stick. And we know that this extra weight, the W here, is pushing downward on the meter stick because the MW has its own diagram that is force, gravity on the weight, and FW. And it's this FW that is that FW pushing down on the meter stick. So the weight is held up by that force and the meter stick is pushed down by that force. So what we need to calculate is torque of gravity. So the torque of gravity should be plus or minus the force of gravity times the leverage distance of gravity. So it's just a generic equation with subscripts on it. And the first thing we need to figure out is if this thing is pivoting, is sitting on a pivot point here. Here is gravity is kind of trying to make it go downward. And that is a negative torque because clockwise is defined as our negative direction. So this is going to be negative. And what is the force of gravity? Well, it's just m times 9.8. And then what is the leverage of gravity? That is this distance here between the pivot point and the actual force. And that is 20 centimeters. Then the torque of the weight is torque of the weight is equal to plus or minus the force of the weight times the leverage distance of the weight. And we have to take a look at this and we have to think, oh, this is a torque weight equals positive because it's exerted to the left of the pivot point downward, which tends to rotate the whole thing counterclockwise, which is our positive direction. And then the force of the weight is the mass of the weight, which is 150 times 9.8 times, and we need the distance is 10 centimeters. And then we plug those things in, and we realize that we can cancel out the G's. So the fact that I didn't do my unit conversions doesn't really matter because it was all proportional stuff. And we end up with 150 times 10 is equal to the mass times 20, which is how we end up getting M is 75 grams. And since I didn't convert my units in the first place, then I don't need to convert from kilograms back to grams at the end, and I just get 75 grams as my result.